Hi, everyone. I know we're at the end of the day. I'm Frances Amatruda. I'm a Sustainability Program Manager with Meta, and I have the honor to present with my colleague here.
Hi, folks. This is Shruti Sethi here. I'm a PM with Azure Storage, Microsoft.
And so today what we're going to be talking about is why do we need to start addressing data center carbon emissions now? Why can't we just wait for a few more years and deal with this, 2029 sounds great. So to set the stage first, I think everyone who's in this room probably realizes our climate is changing. We've lived through wildfires, droughts, heat waves, freak winter storms, all of that. According to the best available science right now, if the world continues kind of unabated on this path, we're looking at almost a 5 degrees Celsius warming by 2100. But even if all of the countries meet their global commitments, their targets, their goals, we're still looking at about a 2.1 degrees Celsius increase in global temperatures by 2100 again. And I don't share this to be all doom and gloom today, but what I really try to take away from this is that there is a critical role for private industries to help us fight climate change. We can't leave this just up to national commitments. The data center industry accounts for a significant percentage of carbon emissions, in some estimates being higher than aviation. But the good thing is with that large contribution or potential contribution to climate change, we also are an industry where there's a lot of leading commitments to combat climate change. What I have up here is by no means an exhaustive list of the public commitments that the OCP community has made in this space, but I just wanted to bring this up to show everyone there is a lot of great leadership happening within the hyperscaler community. And you'll see some variation here, some 2030, 2040, 2050 end dates, but you'll also see some trends emerge with just, once again, a sampling here. You'll see net zero starting to come out as kind of a common theme against these goals. And you'll also see a lot of them are now talking about the entire value chain. What's the entire upstream and downstream impacts and whole, value chain systems that allow these companies to operate, and setting net zero goals that cover that incredibly expansive world of those upstream and downstream emissions.
Okay, so with that foundational understanding, we know that carbon impact is affecting us, and there are countries putting up goals, and there are companies putting up goals. We wanted to highlight three main levers that we have to bring down carbon in the data center world. So the three that we are highlighting over here is essentially facility, hardware, and software. And the three have a very close interconnection or have a very good interplay to actually bring about what we would want, like a green data center or green cloud, the North Goal. To give you a few examples, if I'm putting in the design for the next facility, there needs to be an understanding of how much power the hardware and software systems are going to consume, which essentially means if there are power efficiency, which is related to carbon efficiency, if there are power efficiency initiatives going in, that has to be taken into account while designing the facility. Similarly, how efficiently my software can use the hardware affects how much hardware I should put down. And we all know the more hardware I'm putting down, the more carbon impact. So these three levers closely act with each other to bring about or to emit all the carbon that we are trying to beat over here. We'll do a deep dive into each of these and why the 2030 assumed timeline is important for each of these three cases.
So starting with the data center facility itself, and we're going to, for this case, use a hypothetical 2030 end goal, just for this example, but I think it's probably safe to say everyone in this room knows that data centers aren't just born overnight. The construction of them themselves takes a couple of years. And so at that, you're already looking at the data centers that will, have construction starting in 2028, will be what's being built and being turned over in 2030. But in order to do that construction in just 2 short years, you also need typically about 2 years for the design phase for, those future builds. And so that suddenly has us all the way back to 2026 when we're starting to design the data centers that will come online in 2030. And so this really gives us a fairly short window of time to prepare for those designs. The first section here is we need to focus in the next couple of years on identifying, vetting, and incorporating enabling technologies and potential design optimizations. A lot of these things are not either readily available off the shelf to just be dropped into a new design, or they also need to interplay together and have downstream effects. So for example, if you deploy a new, more efficient cooling system, that's of course going to impact the projected power draw of the facility, which you need to know in time to start your power contracting for that new data center. It's a long timeline when you think about all these different steps that impact each other. There's another set of activities where really the value chain, the suppliers need to be leading that decarbonization effort through sourcing renewable energy, through changing their material bases, et cetera. And so if we look at that, even if we even we plan just a super aggressive 2-year timeline for them to be able to actually implement those decarbonization activities, we need to take some time, the next year or two and focus in on getting their buy-in and alignment for this direction and path and where we want the industry to go if we want to meet these aggressive goals that a lot of the, hyperscalers in this space have set. And that's just for kind of the quote unquote easy stuff. We do know how to source renewable energy. But then there's also things where we need to invent entirely new things that may not even exist right now. Something like low carbon concrete or low carbon, other material alternatives. We need a couple of years to be able to develop those alternatives, vet out a lot of them. Some of them won't work. And then identify the successful ones, pilot those so that we feel confident being able to deploy those at scale. But even once we know we have a really good solution, we still need time to potentially build up the supply chain for that new material. Setting up a whole new supply chain, establishing manufacturing facilities, getting them to the production, throughput needed to support something at the scale of a hyperscale data center is not a small task. Throughout all of this, we also need to make sure we are aligning on the appropriate tools and metrics and measurements and have those processes in place. So as we move through this multi-year process, we are, being able to check in and make sure are we actually making the progress that we expect to be seeing with these activities. And also, how do we make sure we can standardize across that industry and support each other on this journey, and also support companies who, maybe in an adjacent industry to be able to leapfrog from what we in the hyperscale and OCP community have already, learned and discovered and help them as well. So now to kind of move on over to the IT hardware side of the, kind of moving down in size. You'll see similar trends on this graph that we saw with data center designs. Racks, let's assume racks and components have about a 2-year purchasing lifespan. That means 2028, the racks and gear we'll be buying in 2030 will start their mass production cycle. If they also have about a 2-year design process for those systems, we once again are looking at kind of a 1, 2, 3 years max to vet and validate before we need to start actually building these things in together. So kind of first off is, once again, sorry. For many of kind of these common, so we have to, start doing that vetting and validation now on what these new green technologies are. And also testing out system or component level changes so that we are confident in those and have a good plan when we go to start the next design cycle. And then the last thing I'll flag before I turn it over is that For many of the common components that we use heavily throughout this industry, CPUs, GPUs, memory, drives, et cetera, we really, once again, need that value chain engagement. It's going to be the manufacturers of those components who can actually change their embedded carbon, and they will be going through that same timeline needed for them to change material selection, manufacturing processes, energy sources. They need to start now so they have the time to do their own vetting, validation, scaling, implementation of those new sources so that they're online, as soon as possible, and so when we start to hit these targets.
Thank you. So I'll actually start with giving 3 examples of the kind of challenges, timeline challenges that my colleague was mentioning over here. So first example, and the first example I'll use is density, which was something pointed out by the previous presentation for folks who have been here. And if I could maybe design a new hardware IT equipment, like the next generation probably, that is denser in terms of performance. Now that could be dense capacity, dense performance, in whatever ability that particular device gives. That essentially means I need to deploy less number or less quantity of that hardware IT equipment to satisfy the same demand. So that can give me a reduction in carbon. But like we said, that's another generation of the device being developed, which means a design cycle, a manufacturing cycle, which brings us back to why it is timeline sensitive, why we need to work on those design changes now. Second example, again mentioned in this room repeatedly, circularity. Now we might think that in circularity, the device is already ready. We just have to deploy it. We can start deploying in 2029, which is great, which might be possible once the entire process is set up. But currently, the aspects that we need to put effort into is setting up the circularity process. What's the verification? What's the recertification that needs to happen? What is the testing that needs to happen on this device before it goes into production for a second life? All of that process setting up actually needs the effort right now in order to reach these goals in this set time. And the last example, which was also mentioned with facility side, which is renewable energy. Now, renewable energy does not only need to be used when the data center is being operated, but even when the devices are being manufactured, even when the hardware IT devices are manufactured. But again, there are renewable energy contracts to be set up. There might be more renewable energy plants to be set up in that particular area in order to support the manufacturing there. So there is a very long timeline in order to make that happen also. Okay, so we looked at facility for a while, and then we looked at the hardware IT equipment. I'll jump to the third lever that we had, that is software. And this has a little different of dynamics going on. I think all of us expect that, okay, software has a smaller timeline, which is on average true, yes. But there are some other type of challenges that software has to handle that we wanted to highlight here. So the very first thing, of course, there are requirement trade-offs. And by trade-offs, I mean there are competing requirements. There are the regular requirements of performance that need to be met. But now there are new set of requirements from sustainability and carbon side that this mastermind or software that is running the entire system has to take into account. But another important part is, for software, there is currently even more difficulty in visibility and tracking of carbon. If I have a software functionality 1 and software functionality 2, both running on my system in order to execute the entire work, how much carbon do I allocate to functionality 1 and how much to functionality 2? Right? So tracking is an even harder problem when it comes to green software. And the last point, because we said that software is hopefully likely to have a smaller cycle or smaller turnaround time, that also means rapid changes happening. That also means many flavors, many versions that now may need to coexist and be managed. So software then brings in these different kind of problems that they need to tackle while they are working towards their green changes. Okay, so with these three buckets that we looked at, the facility, the hardware IT equipment, and the software, there was one more small aspect that we wanted to highlight that all of us keep in mind. It is not AI. AI is the example there. But it's particularly being cognizant of where the market growth is coming from. So if we are seeing that a particular subcategory or industry is the one that is causing the most growth, we need to be proactive in order to make sure that there are sustainability measures or low carbon measures being put into that aspect. If we are late on doing that, we'll probably be at 2030 already. We would have made the growth because we are humankind, we run behind growth, and we would have lost carbon in that run. Okay, let me use the last bit to sort of bring us all back home. So we looked at our three different levers that need to play together closely and need to interact. The facility, the hardware, and the software that need to implement changes soon in order to get to our north goal of green data center or green cloud. We have an important call to action for folks in this room. I'm assuming everybody works in some or the other aspect of facility, hardware, or software. So please try to embed in sustainability into each of these different categories and domains of your work. And of course, we have an OCP sustainability workstream project and multiple work streams going on under that. The link for joining the project is right here. It looks like you folks are interested. That is why you stayed back on the last day in the afternoon to listen to this. So please join our project, and please help us make sustainability happen. We will pause over here. And
yeah, hi. Thank you for the presentation, really nice. If you go one slide back, so my name is Carl. I happen to work in the green data center facility space. We build one data centers. Do you have examples of actually green, for example, infrastructure software? Because I really think that the OpenStack, the Kubernetes can do a lot more, need to work harder on this to really provide us with green infrastructure software.
green infrastructure software, you said?
Yeah, I'm looking for examples for that. Yeah.
Oh, OK. So I'll give you like an easy example from my perspective. So one green change in the software would be if my software was more efficient such that I needed less memory with my processors for executing at the same performance level. That essentially means I'm going to put in less hardware. That essentially means I'm going to save on all the embodied carbon of that hardware. So that is a green software change. Like the green software is actually enabling that carbon savings to happen. Does that make sense?
Yeah, I understand where you're getting at, but I do not really see that really implemented with the Kubernetes and OpenStack communities yet. So I would love to push for that. Yeah.
I agree. We would like to push for that too.
My name is Jeroen van Bemmel. I'm from Exergy. I was on that stage last year presenting about Meta and others and their net zero targets, and I said they have the target 2030, 2040, it varies. But if you look at the actual numbers in 2021, I think Meta was like 20% up. And I just checked for 2022, it was 46% up. So how confident are you that you can make the emissions go down if the last 2 years have been like that?
Yeah, so for Meta specifically, we do publish a pathway to net zero document that has a lot of details on Meta's own strategy towards meeting net zero that you can refer to. But overall, there are several different levers and opportunities being worked on to fulfill this. As this this presentation highlighted, I would say there's no one silver bullet. We need all of these things working in combination together to try to get to something like net zero.
I'll actually add one thing, because Microsoft is the same. Yes. Oh no, I think she answered because she's from Meta. So yes, yeah. But I mean, essentially, yeah, I will say that, yeah, Microsoft is the same. There's actually a little bit of increase that has happened, but and that's essentially happening because all this while, simultaneously, businesses are also seeing an increase in demand, right? Like, we as individuals are becoming bigger users, and that is basically making more support needed from the businesses. Now, one thing how I see this time period is that the initial time period after the goals were set was a little bit, clearing of the clouds kind of time period, like where folks need to sort of see, oh, there is something to be done. And I think a lot of the companies in our value chain, I'm sure a lot of you folks belong to those companies, did real good by actually setting the goals that time, because it forced people to see, okay, what to do. And this is the action time. Like, yes, when you start off, you don't, when you start your car, you don't start at 60 miles an hour. It's sort of like that. So initially, you probably went slow, which means your carbon impact was actually increasing. And then this is the time to actually go at 60 miles per hour so that you can, reach your destination. At least that's how I view this time period. So, yeah.
I got a couple of questions. One is on the density. So you spoke about density tapping into the storage or compute. But when you design this hardware, how do you balance between the blast radius versus rich storage or a compute density, where losing a significant amount of capacity cannot be accepted? And the second question, okay, maybe I'll wait. So the second question, I was just talking to a few folks in the show floor, like some of the CXL products they have, the difference between the active power and the idle power is very minimal. So since this product is, going to be, more prevalent down the line, so is you guys thinking about, coming out with a kind of like a specification, say that there has to be a significant difference between active power and idle power? So that's one. And the last one is for the Azure, is like, just like the Azure cost bills, you guys provide anything related to every customer, like, this is your carbon footprint from the consumption of the Azure.
I'll actually answer the last one because it's the most straightforward. Yes, there is a carbon viewer. Basically, it is Azure Carbon Optimizer that you can see how much carbon is associated with your build services. So you can view that. Of course, the end goal is to be able to even, give the user an understanding and recommendation based on, hey, your workload seems to be going like that, so maybe make this change. North goal is obviously being able to give such recommendations, but right now you can view the carbon impact of the usage. Okay, now going to the other question, sorry.
Do you want?
Okay, I'll start. Go ahead.
From my view, kind of on your first and second questions, on your first one, I think that's where the approach of life cycle assessment and considering particularly life cycle assessment of a fleet or a year of provisioning services, et cetera, becomes really valuable to make sure you can take that holistic view from start to finish and compare an apples to apples comparison on what the carbon impact or other environmental impacts is. And then for regarding embedding it, where I've seen a lot of success, and I think that's a real superpower of OCP, is we have all of these incredible mind trust different working groups focused on their area of expertise. And where I've been really excited to see progression is embedding sustainability within each of the specs that they're publishing and the work product they're producing, and specifically publishing the sustainability metrics or requirements that make sense for that product. Is the difference between active and idle power the most impactful thing for that category. If so, they should be focused on that. If not, they can focus in another area. So that's where I've really enjoyed seeing people come together across OCP and once again, right sizing it for their program and the right topics. Do you have anything to add?
Yeah, I'll just add one quick thing. So because we are talking about power, and that's actually the operational phase, that ties very closely to what is the lifespan, like how long is the operational phase. So when we talk about active power and idle power, I want to be careful in saying, whether having a less difference or more difference is a good thing. Because I could have a case where the active power is very high, idle power is very low, but it actually stays in the active power zone for a while, for a longer period of time, right? So the evaluation more has to be based on how is the usage phase. So that sort of ties into whether that device needs a large difference between the active and idle power, or does it not matter for the device so much?
So on your green software, were you specifically talking about software that's designed today going forward, or are you looking back at all the applications that have existed for 30-some years that haven't been touched for years and how to make them green? Because they were never designed for something like that.
Yes, I absolutely agree. I think, to be honest, it would be a harder challenge for the applications and the software that exists right now to go back and change all their versions and everything that is deployed. I think our first step would be that at least in what is going ahead, we try to incorporate more green software changes within that. And one thing is, just like hardware IT devices come to an end of life, correspondingly, the software is also updated to like the next versioning. So hopefully that next version has the green software changes, and folks don't have to go back and work so much on the previous. It would be great if they can, but I don't want to push them.